Anyways, so for this one it says if a is equal to 5 root 2 and 2a is equal to the square root of 2x, what's the value of x? Well, I know that 2 times a is equal to the square root of 2x. Okay. Well, I know that a equals this stuff, so I'm going to say 2 times a, but a equals this stuff. So 5 root 2. Now, the reason I do it that way is because now I have a number and an x. So this becomes 2 times 5. You only have to multiply by the 5. 10 root 2 is equal to the square root of 2 times the square root of x. So I'm separating those. So now if I divide by the square root of 2, sure. What happens is the square root of 2 divided by the square root of 2 becomes 1, and then over here the square root of 2 divided by the square root of 2 becomes 1. So I'm left with 10 is equal to the square root of x. Huh? Well, what's 2 times 5? Why did I separate those? So if I have, that's a good question. This is a property of exponents. If I say the square root of a times b times c, I can rewrite that as the square root of a times the square root of b times the square root of c. I did that because I was like, oh, look, I have the square root of 2 and I have the square root of 2. I can simplify that. So I separated the 2 and the x so that I could divide both sides by the square root of 2, and that eliminates the square roots of 2. Okay. But now I have 10 equals the square root of x. I need x. So in order to get x out from under there, I got to square it. Remember, whatever I do on one side of the equation, I got to do on the other. So 10 squared is 10 times 10, or 100. And then when you take the square of a square root, they undo each other, and you're just left with x. So the answer is 100. That's it. That's all there is to it.